Good evening, dear student. I received few queries about these type of questions where we have to show that 5 minus root 3 is a irrational number. And apart from this question, there are lots of other questions. Like one question is this: show that 3 root 2 is irrational number. Okay, and few questions are also in exercise. Prove that 3 plus 2 root 5 is a rational number, or these type of number. Okay, so these all questions, for these all questions we are going to use same performa, or you can say same process we are going to follow. These questions are comparatively easy to the questions where we have to prove the irrationality of number. It means prove that root 2, root 3, root 5, root 7 are irrational number. These questions are comparatively easy. Okay, why? Because in these type of question, first we have to keep in our mind that root 2, root 3, root 5, root 7, like this, these type of questions are irrational number, because we already know this. Okay, so how to solve? Okay, for these type of question, for this type of question, sorry, for this type of question, we will use again the technique that is called proof by contradiction. Okay, and how we prove that root 2 is irrational? In that question, first we assume that root 2 is a rational number, and then we were trying to prove that, but ultimately we were unable to prove that. Okay, in the same manner we will write here. Okay, what we are going to write: let us assume that 5 minus root 3 is a rational number. If 5 minus root 3 is a rational number, so then we can represent this in p by q form. Okay, then 5 minus root 3 can be written as p by q, or here I am taking a by b. It means numerator upon denominator, where b is not equal to 0, and both a and b are integers. A and b are integers. Clear, children? Okay, now what we will do here, we know only one thing, that root 3 is irrational. We know it. Okay, so what we are going to do, we will transpose this 5 another side, or we can transpose this minus root 3 from here to right hand side, so that we will have positive root 3. Clear? So what we are going to do, I am going to transpose this root 3 right hand side and a by b on left hand side. So here 5, I am going to transpose this right hand side. Okay, minus a by b is equal to this minus root 3, I am going to take right hand side, I am going to keep in right hand side, transpose to right hand side. Okay, so it will be plus root 3. Getting this or not? Okay, now you pay your attention. Okay, what is happening here? You see 5 integer. Okay, a is integer, b is integer, is equal to root 3. Okay, so a and b both are integer, and if we divide two integer, so our answer will be always integer. Not integer, our answer will be always rational. This is integers upon integer, so our answer will be a rational number. Getting this or not? Okay, so if you are going to solve this a and b, it means if you are going to divide two integer, our answer will be rational number. So this complete unit will be a rational number. 5 is integer, it means rational number, automatically it will be. So rational number minus rational number, our answer will be again rational number. When we subtract, add, multiply or divide two rational number, our answer will always rational number. So here this complete unit, it means a rational number minus rational number, so answer will be rational number. Okay, so in this equation, this will be our equation 1. In equation 1, a, b and 5 are integers. So a upon b will a rational number, as well as 5 minus a upon b will be a rational number. Why? Because we are subtracting two rational number. When we add, multiply, subtract or divide two rational number, our answer will always rational number. So now in equation 1, okay, right hand side, So our left hand side, this complete one is rational number, and right hand side is root 3. Okay, so what is happening here? What is happening here in equation number 1, LHS. LHS is a rational number. Why this is rational number? I have already told, integer divisible by integer. It means this is rational number, and rational number minus rational number, again rational number. So this complete one will be rational number. Is a rational number. So right hand side RHS will also be a rational number, or we can say root 3 will a rational number. But we know, student, root 3 is irrational number. Getting this or not? We have already proved this, but root 3 is irrational number. Root 3 is irrational number. So what happened? Why this contradiction is arising? This contradiction is arising because of our wrong assumption. Okay. Because of our wrong assumption. So 5 minus root 3 is irrational. It is an irrational number. Clear? In the same way, children, in the same way, you will solve another question. Like here, you see. Okay, 3 into root 2. So what is happening? Again, same performance, same process you will do. Let us assume contrary to this, that 3 let us assume contrary to that. Okay, 3 root 2 is a rational number. If 3 root 2 is a rational number, so it can be written in a by b form. Okay, where a and b both will be integer and b is not equal to 0. So now what is happening here? 2 we will keep this side, and 3 we will transpose another side. Okay, 3 is in multiplication here, so it will be in denominator here. So root 2 is equal to a upon 3b. Again, now you keep your focus here. What is happening here? Right hand side, 3 integers, b is also integer, and a is integer. So integer into integer, again integer. Okay, and if you are dividing an integer by an integer, so our result will be a rational number. So what is happening again here? Right hand side is a rational number, so 2 will be rational number, but we know that 2 is not a rational number, it is an irrational number. So again contradiction is arising. And why this is arising? Because of our wrong assumption. So it means whatever we have assumed that 3 root 2 is rational number, our assumption was wrong, and 3 into root 2 is an irrational number. Getting this or not? In the same manner you will prove this. Clear this, children? Okay, so you revise, you repeat